This chapter is on trig identities. This is the second part of the trig that we're going to do. A lot of this, again, you should have seen most of this. Well, this first stuff, we saw this in the last chapter. So basically, trig identities are relationships between trig functions. Okay, so how are sine and tangent related? How are secant and tangent related? And so on. First, we have reciprocal identities. And this is all stuff that you know. You know that sine of theta is 1 over cosecant because cosecant is 1 over sine. You know that secant is 1 over cosine. You know that cotangent is 1 over tangent, right? We know all this. Then there are the two quotient identities, which we've also seen, because we know that tangent is sine over cosine, cotangent is cosine over sine. None of this is new, right? It's from last chapter, if anything. So let's just apply that to these. We have cosine of theta is 3 over 4. We want to find secant. So what you want to do is, you're given one, you need to find the other. You have to find an identity that relates the two. Cosine and secant are related by this identity. So that's the one I'm going to use. Okay? Secant of theta is 1 over cosine of theta. So this is just 4 over 3. All right? Makes sense? Yeah. Now, here I have secant of x, tangent of x, and I need sine of x. So again, how are, those two related to sine? Well, I know that tangent of x is sine x over cosine x. All right? I have tangent. I need sine if only I had cosine. Do I have cosine? I have the secant. So cosine of x is the reciprocal 4 over 5. And now, just simplifying here, if you multiply both sides by cosine, cosine of x, tangent of x equals sine of x. So sine of x is cosine, which is 4 over 5, times tangent, 3 over 4, 3 over 5. Okay. I mean, the math is simple. You can do it in your head. You can just put it in at this step. It's all the same. Okay? It's simple enough that you have a lot of freedom. Yeah.
Can we do a triangle?
No. A lot of these problems in this chapter can be solved using a triangle, but this is on identities. And I want you to be able to use identities. Okay. Here is another, a recall from last chapter. Here we have an angle theta, okay? This is where you have your terminal side and you draw your triangle. And remember what we said is you have a horizontal and a vertical leg when the hypotenuse is 1. And we said the horizontal is cosine, the vertical is sine. Okay, now, if I wanted to, if I call this y and this x, and I wanted to do the Pythagorean theorem, what would that be? Y squared plus x squared equals 1 squared. Well, now, instead of y and x, if I wanted to use the other labels, you would have sine squared theta plus cosine squared theta. So just remember, sine of theta squared is the same as sine squared theta plus cosine squared theta equals 1. So all this is a Pythagorean theorem. Okay? and it's called the Pythagorean identity. You have to know this by heart. There's just no question about it. Now, just for fun, I'm going to take my Pythagorean identity, and like I said, just for fun, I'm going to divide through by cosine squared theta. Why? Because it's fun. So let's see what we get when we do that. Right. Here I get tangent squared theta. Cosine over cosine, that's 1 equals 1 over cosine secant squared theta. Believe it or not, that's a second Pythagorean identity. Now, I'm going to take the identity. This time, there's more. Bear with me here, Stephen. This time, we're going to divide by sine. One plus cotangent squared theta equals cosecant squared theta. This is the third identity. Now, as you know, there are 3 Pythagorean identities. You have to know all 3 of them. However, the only one I've memorized is the first one. Everybody knows sine squared plus cosine squared equals 1. I've only memorized the first one. To this day, I still get confused where the 1 goes with these. Okay? I know this one, I quickly derive the other 2. Okay? So, at the end of the day, you should be able to come up with these at a moment's notice. It's enough to just know the first one and derive the other 2. So those are the Pythagorean identities. Okay, here I have cotangent of theta is 2. Cosine is less than 0. We need to find sine and cosine. If cosine is less than 0, that's in these quadrants. If cotangent is positive, it's here. Okay? That means my answer is in which quadrant? 3. Now, you can totally do this using the triangle, but not allowed to. Okay? I will take points off otherwise. So here's what you do. You have to use the identities. Okay? You're given cotangent. Find an identity that relates cotangent to either sine or cosine. Well, what's cotangent squared plus 1? Cosecant squared theta. So cotangent squared theta plus 1 is cosecant squared theta. All right, cotangent is 2. Cotangent squared is 2 squared plus 1 is cosecant squared theta.
So it equals 5.
So 5 is cosecant squared theta. I take a square root. So what's cosecant equal to? Nope. Plus or minus root 5. Now, okay, my solution is supposed to be in quadrant 3. In quadrant 3, cosecant is negative, right? Mm-hmm. So I take the negative one. Okay, look, cosecant. I got that cosecant is plus or minus root 5. My solution is supposed to be in quadrant 3. In quadrant 3, cotangent is positive. Everything else, including cosecant, is negative. So I narrow down the plus or minus to just negative. Okay? That's fine. I need sine and cosine. If cosecant is negative root 5, sine theta is 1 over negative root 5. Negative root 5 over 5. What about cosine? Okay, so cotangent of theta is cosine theta over sine theta. So sine theta times cotangent theta is cosine theta. So what's cosine theta? Negative root 5 over 5 times 2. Negative 2 root 5 over 5. Okay? Makes sense? No. We're given that cotangent is positive. That's in these two quadrants. We're given that cosine is negative. That's in these two quadrants. The quadrant where both match is number 3. Okay. So, cofunctions. Alright, so some of these functions, right? Sine, cosine, tangent, cotangent, secant, cosecant. One is co of the other, okay? It's not just a coincidence. The way they match is this. Sine of an angle and cosine of an angle are the same if one angle is 90 minus the other. What does that mean? If I have sine of 40, that equals the cosine of, what's 90 minus 40? 50. See what I mean? So if I have sine of 20, that's the cosine of what? 70. Yes. These are cofunctions. So if I have secant of 35, that's the cosecant of 90 minus 35, which is 55. Yeah. Okay, so sine with cosine, secant with cosecant. Okay. So if I have the cosecant of 10, that's the secant of what? 80. Isn't that cool?
Yeah.
So cool.
Who came up with this?
The Greeks.
Oh, you're very smart. They come up with everything.
Trig is all about the Greeks.
Like that guy, the one who says no.
That guy, Pythagoras. Right. So, in more formal form, cofunction identities are what these are called. So if you have sine of theta, that's the same as cosine 90 or pi over 2 minus theta. Cosine is sine of pi over 2 minus theta, and so on. Okay? Now, what are the what are the odd and even identities? We've sort of touched on this before. If you have a negative angle, sine is an odd function. So if the angle is negative, it's the same as negative sine theta. So for example, if you have sine of negative 20, that's the same as negative sine 20. Okay? Same thing with the tangent. If you have tangent of negative 20, it's the same as negative tangent 20. The only difference, now cosecant and cotangent are the same. The only rebel is the cosine. That's an even function. So if you change the argument to a negative, the value stays the same. So basically, cosine of negative 10 is the same as cosine of 10. Okay? So look, cosine is an odd function. Even function. So whether you have a negative angle or the positive of that angle, the y value is the same. You see? Sine is an odd function, so it looks like this. So if you have a negative angle or a positive angle, it's opposite y values. Okay? Alright, so let's do this one. This one combines even and odd and cofunction ones. Okay, so you have cosine of x equals this. You want to find this. Now, what does the actual identity say? If you see something minus pi over 2, that should remind you of cofunction identity. What does the cofunction identity say? It says sine of pi over 2 minus theta equals cosine of theta. I can switch these to x because I'm working with x's here. Right. But look, what I have here is opposite to what I have here. Therefore, this is the negative of that. Right? Here, the actual identity is pi over 2 minus x. Here I have x minus pi over 2. So one is the negative of the other. So this is sine of negative, what is it? Pi over 2 minus x, which is negative cosine of x. Okay?
And then it's 0.75.
Right. So what's cosine of x? Negative 0.75?
Yeah, so then it's just 0.75.
Right.
Got it.
Okay. Yeah. Okay, so simplifying means to reduce it into a form where you can no longer perform any type of operations. Usually this means, it's reduced to just one trig function, okay? A couple of strategies is you can rewrite it in terms of one trig function or in terms of sine and cosine only, okay? So let's do a couple. All right, for the first one, you have 1 over cosine and then 1 minus sine squared. As a hint, whenever you have a 1 and then plus or minus something squared, you always want to go to your Pythagorean identities. The Pythagorean identities say sine squared x plus cosine squared x equals 1. If you just rearrange that, cosine squared x is 1 minus sine squared x. Yes? So now, this is just cosine squared x. So I have 1 over cosine x, cosine squared x, and that's just cosine x. Okay? So that's just a baby one. Okay, here, that's what we're going to do. So you have a cosine and a sine, and you have a tangent. It's easiest to just make this into a sine over cosine. Yeah.
Not these ones, the really hard ones.
So when you do this, the cosines go away. Now I have sine minus sine times cosine squared. What can I do with the signs?
Divide it out.
I can factor out a sine of x. So I get 1 minus cosine squared x. And from this identity, that's just sine squared x. So this is sine of x times sine squared x. So that's sine cubed x. Okay? It is. Right until you start the identities, verifying identities. Yeah, that's the fault. That's the next section.
These are fast times of
The extremely hard ones.
When you have something like this, the trick is to always make a common denominator. Okay? Alright, that's the common denominator. So the first one, right, you cancel with this one, so you have 1 plus secant x times secant x. Minus second denominator, I'm just doing a common denominator. Second denominator with this, you have 1 minus secant times secant. Okay, distribute the secants. So it's minus secant x plus secant squared x over, you have 1 minus secant, 1 plus secant, a minus b, a plus b. What does that give you? 1 minus secant squared x, right? Because if you have, no. Everybody, wait, is everybody okay with the bottom here?
I'm still on the problem.
Wait,
So the second term was a plus. The secants will go away. Here I have 2 secant squared x over. Now, what's 1 minus secant squared x? What's the identity?
1 plus secant squared x.
No. It's tangent squared x plus 1 equals secant squared x. Meaning, 1 minus secant squared x is negative tangent squared x. Okay? So here, this becomes negative tangent squared x. And now, we're going to change everything in terms of sine and cosine. So on the top, I have 2 over cosine squared x over negative sine squared x cosine squared x. Cosine squared x's go away. You have negative 2 over sine squared, which is negative 2 cosecant squared x. Well, this became negative for the tangent, and it stays. So this is the final answer.
oh yeah, I remember last year he used to call them like cis and cot.
Oh my
That was so
god.
funny.
Okay,
Wait, so cot
a very easy way to do this one. Because 1 plus tangent squared is what?
Secant squared.
Secant squared x
Oh, so it's 1. Oh, no.
over cosecant squared x. Secant is 1 over cosine. Cosecant is 1 over sine. So this is 1 over cosine squared x times sine squared x over 1. Okay, dividing two fractions is multiplying one by the reciprocal of the other. So sine squared x over cosine squared x, tangent squared x. Okay? Now, this homework, yeah.